The aircraft was then delivered on the 20th of February, 2018 to Qatar Airways, which had also been the launch operator of the -900, and entered the commercial service with a flight from Doha to London on the 24th of February, 2018. Shorter A350-800, edit. The 60.45 m, 198.3 feet, long A350-800 was designed to seat 276 passengers in a typical 3-class configuration with a range of 15,270 kilometers, 8,245 mi, 9,488 mi, with an tow of 259 tons. 571,000 pound. In January 2010, Airbus opted to develop the -800 as a shrink of the baseline -900 to simplify development and increase its payload by 3 tons, 6,600 pound, or its range by 460 kilometers, 215 mi, 290 mi. But this led to a fuel burn penalty of a couple of %, according to John Lee. The previously planned optimization to the structure and landing gear was not beneficial enough against better commonality and maximum takeoff weight increase by 11 t from 248 t. The 800's fuselage is 10 frames shorter, 6 forward and 4 aft of wing, than the 900 aircraft. It was designed to supplement the Airbus A330-200 long-range twin. Airbus planned to decrease structural weight in the -800 as development continued, which should have been around airframe 20. While its backlog reached 182 in mid-2008, it diminished since 2010 as customers switched to the larger -900. After launching the Airbus A330neo at the 2014 Farnborough Airshow, Airbus dropped the A350-800, with its CEO Fabrice Brigia saying, "I believe all of our customers will either convert to the A350-900 or the A330neo." He later confirmed at a September 2014 press conference that development of the A350-800 had been cancelled. There were 16 orders left for the -800 since Yemenia switched to the -900 and Hawaiian Airlines moved to the A330neo in December 2014, 8 for Aeroflot and 8 for Asian Airlines, both also having orders for the -900. In January 2017, Aeroflot and Airbus announced the cancellation of its -800 order, leaving Asian Airlines as the only customer for the variant. After the negotiation between Airbus and Asian Airlines, Asian converted orders of 8 A350-800s and 1 A350-1000 to 9 A350-900s. Longer A350-1000, edit. In 2011, Airbus redesigned the A350-1000 with higher weights and a more powerful engine variant to provide more range for trans-Pacific operations. This boosted its appeal to Cathay Pacific and Singapore Airlines, who were committed to purchase 20 Boeing 777-9s, and to United Airlines, which was considering Boeing 777-300s to replace its 747-400s. Emirates was disappointed with the changes and cancelled its order for 50 A350-900s and 20 A350-1000s, instead of changing the whole order to the larger variant. Assembly of the first fuselage major components started in September 2015. In February 2016, final assembly started at the A350 final assembly line in Toulouse. 3 flight test aircraft were planned, with entry into service scheduled for mid-2017. The first aircraft completed its body join on the 15th of April 2016. Its maiden flight took place on the 24th of November, 2016. The A350-1000 flight test program planned for 1,600 flight hours, 600 hours on the first aircraft, MSN-59, for the flight envelope, systems and power plant checks, 500 hours on MSN-71 for cold and warm campaigns, landing gear checks and high-altitude tests, and 500 hours on MSN-65 for route proving and ETOPS assessment, with an interior layout for cabin development and certification. In cruise at Mach 0.854, 911.9 km per hour, 492.4 kN, and 35,000 feet, its fuel flow at 259 t, 571,000 pound, is 6.8 t, 15,000 pound, per hour within a 5,400 nautical miles, 10,000 kilometers, 6,200 mi, 11. Plus 1 2 hours early long test flight. Flight tests allowed raising the MTO from 308 to 316 t, 679,000 to 697,000 pound. The 8T, 18,000 pound, increase giving 415 mi, 830 kilometers, 520 mi, more range. Airbus then completed functional and reliability testing. Type certification was awarded by EASA on the 21st of November, 2017, along FAA certification. The first serial unit was on the final assembly line in early December. After its maiden flight on the 7th of December, 2017, delivery to launch customer Qatar Airways slipped to early 2018. The delay was due to issues with the business class seat installation. It was delivered on the 20th of February, 2018 and entered commercial service on Qatar Airways Doha to London Heathrow route on the 24th of February, 2018. Possible further stretch, edit. Airbus has explored the possibility of a further stretch offering 45 more seats. A potential 13 feet, stretch would remain within the exit limit of 4 door pairs, and a modest MTO increase from 308 t to 319 t would need only 3% more thrust, within the Rolls-Royce Trent XWB-97 capabilities, and would allow a 7,600 mi, 14,100 kilometers, 8,700 mi, range to compete with the 777-9's capabilities. This variant was to be a replacement for the 747-400, tentatively called the A350-8000, -2000 or -1100. At the June 2016 Airbus Innovation Days, Chief Commercial Officer John Lee was concerned about the size of a 400-seat market besides the Boeing 747-8 and the 777-9, and Chief Executive Fabrice Brigia feared such an aircraft could cannibalize demand for the -1000. The potential 79m long, 258 feet, aeroplane was competing against a hypothetical 777-10X for Singapore Airlines. At the 2017 Paris Air Show, the concept was shelved for lacking market appeal, and in January 2018 Brigia focused on enhancing the A350-900/1000 to capture potential before 2022/2023, when it would be possible to stretch the A350 with a new engine generation. Improvements, edit. Performance Improvement Package, PIP, 2017, edit. In October 2017, Airbus was testing extended sharklets as part of the upcoming Performance Improvement Package, PIP, which could offer 114 mi, 185,259 km, 115,161 mi, extra range and reduce fuel burn by 1.6%. The wing twist is being changed for the wider, optimized span load pressure distribution, and will be used for the Singapore Airlines A350-900 ULR in 2018 before spreading to other variants. On the 26th of June, 2018, Iberia was the first to receive the upgraded -900, with a 280T, £620,000, NTO version for an 8,200 mi, 15,200 km, 9,400 mi, range with 325 passengers in 3 classes. This eventually became a standard package for all the A350-900 airframes starting from MSN 216. Hybrid Laminar Flow Control, HLFC, edit. By April 2019, Airbus was testing a hybrid laminar flow control, HLFC, on the leading edge of an A350 prototype vertical stabilizer, with passive suction similar to the boundary layer control on the Boeing 787-9 tail, but unlike the natural laminar flow blade, within the same EU Clean Sky program. New Production Standard, NPS, 2022, edit. On the 30th of September, 2022, an improved New Production Standard, NPS, was announced. It will apply to a 359/35K airframes starting from MSN 579, which is an A350-900 airframe that was delivered to Iberia. The NPS includes a 1.2T, 2,600 pound, weight reduction and a 3T, 6,600 pound, NTO increase, along with a wider interior cabin to offer 30 additional seats. It offers the customers with a new weight variant WV020 for the 283 Team 2. The interior changes include moving the cockpit wall forward, moving the aft pressure bulkhead one frame further aft and resculpting the side walls to allow 10 across 17-inch seats. Also, there are improvements to the aircraft's takeoff performance by introducing software evolutions which regulate the slat and flap positions, and has also implemented a faster landing gear retraction cycle conferring greater obstacle clearance and reduced aerodynamic drag. New engine option, edit. By November 2018, Airbus was hiring in Toulouse and Madrid to develop a re-engined A350neo. Although its launch is not guaranteed, it would be delivered in the mid-2020s, after the A321XLR and a stretched A320neo Plus, potentially competing with the Boeing new midsize airplane. Service entry would be determined by ultra-high bypass ratio engine developments pursued by Pratt & Whitney, testing its geared turbofan upgrade, Safran aircraft engines, ground testing a demonstrator from 2021, and Rolls-Royce, targeting a 2025 ultrafan service entry. The production target is a monthly rate of 20 A350neos, up from 10. In November 2019, General Electric was offering an advanced GX1 variant with a bleed air system and improvements from the GE9X, developed for the delayed Boeing 777X, to power a proposed A350neo from the mid-2020s. In 2021, Rolls-Royce signed an exclusive deal to supply A350-900 engines until 2030, following previous similar commitments for the A350-1000. Design, edit. Airbus expected 10% lower airframe maintenance compared with the original A350 design and 14% lower empty seat weight than the Boeing 777. Design freeze for the A350-900 was achieved in December 2008. The airframe is made out of 53% composites, CFRP for the empennage, vertical and horizontal tail planes, the wing, center and outer box, including covers, stringers, and spars, and fuselage, keel beam, rear fuselage, skin, and frame. 19% aluminium and aluminium lithium alloy for ribs, floor beams, and gear base, 14% titanium for landing gears, pylons, and attachments, 6% steel, and 8% miscellaneous. The A350's competitor, the Boeing 787, is 50% composites, 20% aluminium, 15% titanium, 10% steel, and 5% other. Fuselage, edit. The A350 features a new composite fuselage with a constant width from door 1 to door 4, unlike previous Airbus aircraft, to provide maximum usable volume. The double-lobe, ovoid, fuselage cross-section has a maximum outer diameter of 5.97 m, 19.6 feet, compared to 5.64 m, 18.5 feet, for the A330/A340. The cabin's internal width is 5.61 m, 18.4 feet, at armrest level compared to 5.49 m, 18.0 feet, in the Boeing 787 and 5.87 m, 19.3 feet, in the Boeing 777. It allows for an 8:2-4-2 arrangement in a premium economy layout, with the seats being 49.5 centimeters, 19.5 in, wide between 5 centimeters, 2.0 in, wide armrests. Airbus states that the seat will be 1.3 centimeter, 0.5 in, wider than a 787 seat in the equivalent configuration. In the 9/333 standard economy layout, the A350 seat will be 45 centimeters, 18 in, wide, 1.27 centimeter, 0.5 in, wider than a seat in the equivalent layout in the 787, and 3.9 centimeters, 1.5 in, wider than a seat in the equivalent A330 layout. The current 777 and future derivatives have 1.27 centimeter, 0.5 in, greater seat width than the A350 in a 9 configuration. The 10 seating on the A350 is similar to a 9 configuration on the A330, with a seat width of 41.65 centimeters, 16.4 in. Overall, the A350 gives passengers more headroom, larger overhead storage space, and wider panoramic windows than current Airbus models. The A350 nose section has a configuration derived from the A380 with a forward-mounted nose gear bay and a 6-panel Flytech windscreen. This differs substantially from the 4-window arrangement in the original A350XWB design. The new nose, made of aluminium, improves aerodynamics and enables overhead crew rest areas to be installed further forward and eliminate any encroachment in the passenger cabin. The new windscreen has been revised to improve vision by reducing the width of the center post. The upper shell radius of the nose section has been increased. The Airbus A350 initially featured manual window shades. In 2020, Airbus announced that dimmable windows, similar to those on the Boeing 787, would be offered as an option. These windows are designed to darken or lighten more efficiently, providing greater control over light levels while maintaining an outside view. Starlux Airlines became the first carrier to receive a A350s equipped with dimmable windows across all cabins, while Japan Airlines offers this feature exclusively in premium economy and higher class cabins, retaining manual shades for economy passengers. Wing. edit. The A350 features new composite wings with a wingspan that is common to the proposed variants. Its 64.75 m, 212.4 feet, wingspan stays within the same ICAO aerodrome reference code E65M limit as the A330 /A340 and the Boeing 777. The A350's wing has a 31.9 degrees sweep angle for a Mach 0.85 cruise speed and has a maximum operating speed of Mach 0.89. The -900 wing has an area of 442 m, 4,760 square feet. This is between the 436.8 m, 4,702 square feet, wing of the current Boeing 777-200LR/300 and the 466.8 m, 5,025 square feet, wing of the in-development Boeing 777X. However, Boeing and Airbus do not use the same measurement. The A350-1000 wing is 22.3 m, 240 square feet, larger through a 30 cm, 12 in, extension to the inboard sections of the fixed trailing edge. A new trailing edge high lift device has been adopted with an advanced dropped hinge flap similar to that of the A380, which permits the gap between the trailing edge and the flap to be closed with the spoiler. It is a limited morphing wing with adaptive features for continuously optimizing the wing loading to reduce fuel burn, variable camber for longitudinal load control where inboard and outboard flaps deflect together and differential flaps setting for lateral load control where inboard and outboard flaps deflect differentially. The manufacturer has extensively used computational fluid dynamics and also carried out more than 4,000 hours of low and high-speed wind tunnel testing to refine the aerodynamic design. The final configuration of wing and winglet was achieved for the Maturity Gate 5 on the 17th of December, 2008. The wingtip device curves upwards over the final 4.4 m, 14 feet. The wings are produced in the new £400 million, US $641 m, 46,000 m, 500,000 square feet, North Factory at Airbus Broughton, employing 650 workers, in a specialist facility constructed with £29 million of support from the Welsh Government. Undercarriage, edit. Airbus adopted a new philosophy for the attachment of the A350's main undercarriage as part of the switch to a composite wing structure. Each main undercarriage leg is attached to the rear wing spar forward and to a gear beam aft, which itself is attached to the wing and the fuselage. To help reduce the loads further into the wing, a double side stay configuration has been adopted. This solution resembles the design of the Vickers VC-10. Airbus devised a three-pronged main undercarriage design philosophy encompassing both 4- and 6-wheel bogies to stay within pavement loading limits. The A350-900 has 4-wheel bogies in a 4.1 m, 13 feet, long bay. The higher weight variant, the A350-1000 uses a 6-wheel bogie, with a 4.7 m, 15 feet, undercarriage bay. French-based Messier Doughty provides the main undercarriage for the -900 variant, with titanium forgings from Kobelco, and UTC Aerospace Systems supplies the -1000 variant. The nose gear is supplied by Liebherr Aerospace. 1. The A350-900 has a 4-wheel main gear for a 283T, 624,000 pound, tow. 2. The A350-1000 has a 6-wheel main landing gear to support a 322T, 710,000 pound, tow. Systems, edit. Honeywell supplies its 1,700 horsepower, 1,300 kilowatts, HGT 1700 auxiliary power unit with 10% greater power density than the TPE 331 from which it is developed, and the air management system, the bleed air, environmental control, cabin pressure control and supplemental cooling systems. Airbus says that the new design provides a better cabin atmosphere with 20% humidity, a typical cabin altitude at or below 6,000 feet, 1,800 m, and an airflow management system that adapts cabin airflow to passenger load with draft-free air circulation. The ram air turbine, with a nominal power of 50 kV, is supplied by Hamilton Sundstrand and located in the lower surface of the fuselage. In light of the 787 Dreamliner battery problems, in February 2013 Airbus decided to revert from lithium-ion to the proven nickel-cadmium technology, although the flight test program will continue with the lithium-ion battery systems. In late 2015, a 350XWB MSN 24 was delivered with 80 kilograms, 176 pound, lighter SAFT Li-ion batteries, and in June 2017, 50 A350s were flying with them and benefiting from a 2-year maintenance schedule instead of NICT's for 6 months. Parker Hannifin supplies the complete fuel package, inerting system, fuel measurement and management systems, mechanical equipment and fuel pumps. The fuel tank inerting system features air separation modules to generate nitrogen-enriched air to reduce the flammability of fuel vapor in the tanks. Parker also provides hydraulic power generation and distribution system, reservoirs, manifolds, accumulators, thermal control, isolation, software and new engine and electric motor-driven pump designs. Parker estimates the contracts will generate more than $2 billion in revenues over the life of the program. Cockpit and avionics, edit. The revised design of the A350XWB's glass cockpit dropped the A380-sized display and adopted 38 cm, 15 in, liquid crystal display screens. The new 6-screen configuration includes 2 central displays mounted one above the other, the lower one above the thrust levers, and a single, for each pilot, primary flight forward/navigation display, with an adjacent onboard information system screen driven by laptops running EFB software which are connected while stowed behind each pilot. Airbus says the cockpit design allows for future advances in navigation technology to be placed on the displays, plus gives flexibility and capacity to upload new software and to combine data from multiple sources and sensors for flight management and aircraft systems control. An optional head-up display is also present in the cockpit. Avionics are a further development of the Integrated Modular Avionics, IMA, concept found on the A380. The A350's IMA will manage up to 40 functions, versus 23 functions for the A380, such as undercarriage, fuel, pneumatics, cabin environmental systems, and fire detection. Airbus stated that the benefits includes reduced maintenance and lower weight because as the IMA replaces multiple processors and LRUs with around 50% fewer standard computer modules known as line replaceable modules. The IMA runs on a 100 Mbit /S network based on the avionics full duplex switched Ethernet standard, as employed in the A380, in place of the architecture used on the A330 /A340. Engines, edit. In 2005, GE was the launch engine of the original A350, aiming for 2010 deliveries, while Rolls-Royce offered its Trent 1700. For the updated A350XWB, GE offered a 87,000 lbf, 390 kN, GX 387 for the A350-800/900, but not a higher thrust version needed for the A350-1000, which competes with the longer range 777 powered exclusively with the GE90-115B. In December 2006, Rolls-Royce was selected for the A350 XWB launch engine. The Rolls-Royce Trent XWB features a 300 cm, 118 in diameter fan, and the design is based on the advanced developments of the Airbus A380 Trent 900 and the Boeing 787 Trent 1000. It has 4 thrust levels to